Welcome to the Deep Dive. Today we're charting a really fascinating journey of transformation. We'll be digging into this career and, I guess, the worldview of a pretty successful tech leader. Our sources lay out this path connecting, well, cutting-edge Gen AI, deep computer science roots, a major personal change, and this unique philosophical view on how we should handle tech.
Yeah, we're looking at Jon White. He's a technical architect, a leader, and also teaches at Morgan State University. What really stands out, I think, is how he's seen technology over the last 20 years. It's not just about code. For him, it's deeply tied into faith, ethics, moral questions, a really interesting mix. We'll follow his path from, highly classified government work to really pushing the boundaries in open source AI today.
Okay, great. So let's start right at the beginning then.
Yeah.
Jon White grew up near D.C., Oxon Hill area, working middle-class family, big emphasis on education. He mentions having this analytical mind early on. Math was easy for him, but high school, he called himself an underachiever.
Yeah.
Not failing, but sort of coasting. A 3.0 GPA, but also dealing with low self-esteem, depression, and, well, partying, smoking.
Right, and that internal struggle is kind of key because it sets up this huge shift later on.
Right.
That underachievement kind of carried over into his first year at Morgan State studying computer science. Still more focused on partying, apparently, just doing the minimum. But then somewhere in that first year, he talks about having this major epiphany.
And this wasn't like a slow dawning realization, was it? The sources make it sound quite dramatic, an extreme personality change.
Exactly. He describes consciously deciding to switch his whole social scene, left the party friends, went all in, as he put it, with the study group, and suddenly it clicked. He wasn't just getting by, he started excelling, really fell in love with algorithms, programming, the whole thing.
Okay, so that academic drive kicks in. That sets up his career path. But then there's a second big shift, more personal, around age 30.
Yeah. Professionally, things were going well, but he felt this longing, he called it, a distance from his Baptist upbringing. He realized he needed a different kind of foundation internally if he wanted to be the person, the husband, the father he aimed to be.
Which led him to recommit to his faith quite profoundly. He uses the term born again.
Oh.
But let's connect this back. This wasn't just a private matter. It directly changed how he operated professionally, didn't it?
Oh, absolutely. He's quite open about it. Says before that change, he could be arrogant and selfish. Apparently judged colleagues mostly on their technical chops.
And after, what was the practical difference in his leadership?
It shifted his priorities. It wasn't just about the code or the project outcome anymore. It became about valuing the people, honoring them, actively mentoring them, helping them, get to the next level, professionally and personally.
And that dedication to transformation, which led to him being married, 5 kids, serving as a pastor now, that same all-in intensity shows up in his technical work too. Where did we first see that really focused approach technically?
I'd say it really started showing in college with a NASA grant internship. He got paid to work on something called a Beowulf cluster. Now, for listeners who might not know, this was like an early do-it-yourself supercomputer built from standard parts, open source, often used for things like weather modeling back then. The key thing, though, was the skills he picked up. Linux, clustering, networking, even presentation skills. And he specifically notes he's still using variations of those skills today.
Still. That seems almost counterintuitive given how fast tech moves.
Yeah.
But it suggests a really solid foundation.
It really was. And that foundation propelled him into some serious high-level classified work.
Right. He started at Lockheed Martin in 2001. Security clearance, satellite telemetry.
Yeah, processing satellite data. And his timing, getting that clearance just before 9/11, meant his career quickly moved into the intelligence community around Fort Meade, a very demanding, technically advanced environment.
And the problems they were tackling then. Sounds fascinating. Digital signal processing, DSP.
Basically, mathematically manipulating signals like radio waves or images once they're digitized.
And using Java, but also FPGAs. Can you unpack that a bit?
Sure. FPGAs are field programmable gate arrays. Think of them as specialized computer chips. Unlike a regular CPU, you can reprogram them after they're made to be incredibly fast at very specific tasks. So perfect for crunching through huge amounts of signal data really, really quickly, which was vital.
And the context here is important too, right? This was before the huge boom in open source software libraries we have now.
Absolutely. He mentions working on software-defined radio, SDR, with, as he put it, some of the smartest people on the planet.
SDR. So defining radio functions using software instead of fixed hardware.
Yeah, exactly. And if they needed complex tools back then, say, for clustering signals or managing data flow, they often had to build it all themselves. from the ground up. No just grabbing a library off GitHub like today. It was fundamental work.
But he didn't stay siloed in that classified world forever. He made a very deliberate switch later on.
He did. Moved to a company called Red Alpha, specifically to engage with the rise of open source development, things like modern Java frameworks, JSON, single-page web apps, modern UX design. He wanted to be part of that wave.
That sounds like a conscious leap, maybe even a risk, leaving the, perhaps, perceived stability of intelligence work for the faster, maybe messier world of open source.
I think it was a deliberate embrace of that faster cycle. Of obsolescence, really, which fits with his work today as an architect. It's incredibly broad now. Scalable malware processing with Docker, Kubernetes, semantic search, building machine learning models like XGBoost, using advanced databases like SAP Adana, unifying data with tools like Trino or Presto. It's a huge range.
Okay, you mentioned Trino and Presto. Just quickly, for our listener, those are tools that let you query data scattered across lots of different systems, right? Like it's all in one place.
Exactly. Query your data lake, your old database, your cloud storage, all together. Really powerful for unification.
And all this technical velocity, this constant change, leads to a key concept he talks about, the deprecation delta.
Yeah, the deprecation delta. He defines it as the time lag between when you finish building something great and when some new technology emerges that basically forces you to rethink it, or maybe even rebuild it completely.
And his observation is that this delta, this window of time, is shrinking.
Dramatically. He says sometimes it feels like it's down to weeks.
Weeks? Wow.
Yeah, an unprecedented pace in his couple of decades doing this. And that rapid change is a big reason why he's pivoted so hard towards generative AI.
Right, which brings us to what he calls the age of democratized intelligence.
He strongly believes Gen AI is one of the most transformative technologies we've ever seen. Possibly, he thinks, even more impactful than the internet, because it's going to weave into everything. Business, learning, how we solve problems. It democratizes intelligence itself.
And he's not just talking about it, he's actively building in this space.
Definitely. He's currently a fractional CTO for a stealth startup. They're building a conversational learning platform. His big bet there is that voice assistants, not web pages or keyboards, are the future of interaction.
Which means the tough problems aren't just code, are they? It's conversational science, dialogue engineering, getting that interaction smooth and instant at scale.
Exactly. Low latency is key. And this democratization he talks about, it also means incredible speed of deployment. He gives us an amazing example from his consulting work. Built a whole inventory management system for a liquidation company. Using AI, one person, built it in days, not months. Days.
Along a whole system in days. Is that just better cloud tools, or is the AI itself the real game changer there? That sounds almost too good to be true.
Well, it's the AI amplifying the tools. The intelligence layer automates so much of the data structuring, the workflow logic, stuff that used to take weeks of manual coding. And this power, the speed, it feeds directly into how he teaches, too. He's an adjunct professor at Morgan State teaching organization of programming languages. And he poses these really provocative philosophical questions to his students now.
Like the one you mentioned. Is English now a Turing-complete language?
Yeah.
That forces them to think about whether natural language, when understood by an LLM, can basically compute anything computable. That's a mind bender.
It really is. And he uses these tools himself in very practical ways. He mentioned working with Humro. They're a nonprofit focused on psychometric research. They use an early open source LLM to automatically generate draft questions for psychological assessments. That's a task that usually takes human experts weeks, maybe months. The LLM prototyped it much faster.
And he even automated his own grading. That's the ultimate practical application for a professor.
Right. He used tools like GPT-4 or Claude's coding abilities to build an automatic grader for his handwritten quizzes.
Handwritten.
Presumably OCR first, then the LLM logic. But the point was, he whipped up this auto grader in about 2 hours. Minimal fuss. That just shows the speed you can move at now. The development cycle is incredibly compressed.
Which inevitably brings us to the bigger questions, doesn't it? Ethics, consciousness.
When a tool is this powerful, this fast,
Yeah.
who guides it? What principles do we use? Especially when we start thinking about AI consciousness.
And this is where his perspective gets really unique, tying into his faith.
He suggests that maybe quantum physics hints at dimensions beyond the purely physical, a spiritual dimension, which would imply human consciousness isn't just a biological accident of evolution. It connects to a worldview where humans are, created in the image of God, possessing something non-material.
And he contrasts this directly with other big names in AI.
Yeah, he specifically mentions Mustafa Suleyman, Microsoft's AI lead. Suleiman's view, publicly stated, is that consciousness is purely biological. Emergent, maybe, but just biology. And Suleiman argues developers should actually stop trying to make AI seem conscious, because it's just creating an illusion of experience, not the real thing.
That's a fundamental disagreement about the nature of reality, essentially.
It is, and White's argument follows from that. He says if you only have people with a purely materialistic, atheistic, or humanistic worldview working on AI consciousness, you're inevitably going to end up with a subpar view. You're missing a huge piece of the puzzle, the spiritual dimension that he believes actually governs consciousness.
So it's not just abstract philosophy, it's about the potential limitations of AI developed under a narrow worldview.
That's the implication. If your underlying assumptions about reality are incomplete, the systems you design might reflect those limitations, especially when dealing with something as profound as potential consciousness.
So, okay, given that view, what's his proposed solution for managing AI development and deployment? How do we govern this?
His solution is diversity. But not just demographic diversity, worldview diversity. He argues strongly for multidisciplinary teams to oversee AI governance. These teams need everyone. Atheists, religious people, scientists, philosophers, agnostics, artists, people who aren't technical experts. The goal is to ensure that the policies, the ethical guidelines, the design choices, all of it, reflects a broad range of fundamental beliefs about reality, consciousness, and value, not just one narrow slice.
Wow. We've really covered some ground here, from that initial personal struggle
Through decades of intense technical work.
right up to the nature of consciousness and how we should govern AI.
Yeah.
It's quite a trajectory.
Yeah, and I think the key takeaway for you, our listener, really boils down to two things. First, keeping up requires an extreme, all-in approach to adopting new tech, just to stay ahead of that shrinking deprecation delta. Complacency isn't an option. And second, pure technical skill isn't enough anymore. Especially with AI. You need that broader perspective, philosophical, ethical, multidisciplinary, to really grapple with the impact.
Exactly. And that brings us to a final thought. This leader, Jon White, he believes that because the barriers to deploying ideas are so low now, everything's a green field. Okay. So the question for you is, now that these incredibly powerful intelligence tools are becoming democratized, accessible, what massive unsolved problem are you going to tackle? Think big, like he does cheap energy, disease, quantum computing, mental health. The field is wide open. What's your move?